In today's video, we'll be working through dot products. Well, there are three main equations which we are going to be using in this video. The first being the magnitude of our vector equals the square root of v1 squared plus v2 squared. That's equation number one. The second equation we want to use is going to be v times w equals v1 times w1, so it's going to be in parentheses, plus v2 plus w2. The third equation which we are going to be using in this video is w, or work, equals the magnitude of your force times the magnitude of your distance times cosine of theta. And the last equation we need to know for these types of problems is v times w equals the magnitude of v times the magnitude of w times cosine of theta. This equation will primarily be used for finding theta, or the angle in our question. Well, the first practice problem we have says, given u equals 2, 3 and v equals 5, 8, find the following. Well, question A says u times v equals blank. So we need to find what u times v equals. Well, if we look back at our equations, there's one equation in particular which would help us find it. We can see v times w equals this equation. V, w, your names of your components or your vectors can obviously change. So here we have u and v, whereas in our base equation we have v and w. So we're going to use that equation. So if you remember, and this should be in your notes, these equations are pretty important. That equation says v times w equals v1 times w1 plus v2 times w2. Well, v1 and w1. Well, the ones can basically, you can think of them as x. So you could write it as vx times wx. And then the twos, in this scenario, you can think of them as y's. Okay, well, you might be asking, where did we get v and where did we get w? Well, v and w are representing our equations. So we can think of this one, let's just say this one is going to be v in our problem. So we're going to represent v as v, and this u is going to be our w. So we're going to substitute u for w and v for v. So we're going to have u times v equals u1 times v1 plus u2 times v2. That's how we are going to answer problem A. Well, as we said before, the parts which have a subscript of 1 are representing our x values. So we're going to take the x value from our u equation and our y equation and substitute it in for u1 and v1. Well, we can see the x value for our u equation is 2, so right here. And then for our v equation, it's 5. So we have 5 times 2, that's going to be our first parentheses, plus, now we're in u2 and v2. Well, we said the 2 subscript represents the y values. So we have 3 and 8. So we know these are both our y values from our coordinates. So we have 3 times 8. Well, 5 times 2 we know is 10, plus 3 times 8. 3 times 8 is 24. This means this equals 34. So we know u times v equals 34, meaning our answer to number 1A is 34. Now let's go ahead and do question B. So now in order to solve for question B, we are going to use that last equation. And if you remember, that last equation said v times w equals magnitude of v times the magnitude of w times cosine of theta. Well, we can rearrange this question and say cosine of theta equals v times w over the magnitude of v times the magnitude of w. And we can take it a step further and simplify down to theta equals cosine inverse of v times w over magnitude of v times the magnitude of w. Well, now we can use this equation. So we know that v times w, as we said up here, equals v1 times w1 plus v2 plus w2. And we already know that that's 34, right? So we're going to use that same 34 in the numerator of this next question. So let's go do this right here where we have a little more space. So we have cosine inverse of v times w over the magnitude of v times the magnitude of w. Now we will substitute in our values. So we said that v times w, we found it in our first question, was 34. And remember, we're just changing it from w to u as the terms or the variables can be interchangeable. So we have cosine inverse of, we found a to be 34. So we have 34. Now we have to multiply the magnitude of v times the magnitude of w. If we go back to our equations, we said that to find magnitude, take the magnitude, and that equals the square root of v1, w1, or u1, so whatever your variable is, the first term, or your x value squared, plus your y value squared, and then you take the square root of that. So let's go use that right here, and I'll rewrite it to the side. So we have the magnitude of v equals the square root of v1 squared plus v2 squared. Well, now what we need to do is substitute in the values. Well, we know that we made v equal to v, so let's go ahead and do that. So we said v equals 5, 8. So we said x is v1 and y is v2. So we'll take the square root of 5 squared, and we're getting this from our question. 5 squared plus v2 squared. Well, v2 we said is 8 because that's our y value. So we have 8 squared. So we take the square root of 25 plus 64. Well, 25 plus 64 is 89. So we take the square root of 89. And since that's not a perfect square, we're going to leave it just as it is. So far we have the square root of 89. So we have cosine inverse of 34 over the square root of 89, which is our magnitude of v, times, now we need to find the magnitude of w. Well, in our question, we're going to use u as w. Well, we said u is 2, 3. So let's go ahead and do the same thing we just did for v and do it to w. So we said the magnitude of v is going to equal the square root of u1 squared plus u2 squared. Well, u1 is our x-coordinate, which is 2. So we have square root of 2 squared plus, now we need our y-coordinate, which is 3, from the u-coordinate point. So then we have 3 squared. We know that's equal to the magnitude of v. So we take the square root of 4 plus 9, which is the square root of 13. Well, so now we have cosine inverse of 34 over the square root of 18 times the square root of 13. And we know that this equals 1.68468. Let's say we're going to do 3 sig figs, so it's just going to be 1.68 degrees. And in problem 2, it says, given u equals -7, 9 and v equals 2, 3, find the following. U times v, and then b says, find the angle between the vectors u and v. We're going to do the exact same steps we just used in problem 1. Well, if you remember, the first thing we did was solve the first question, and we used one of the equations, which was u times v, or v times w. So v times w equals v1 times w1 plus v2 plus w2 equals v times w. We said v was v and w was u. So let's go ahead and do that. So we said v is v, so we have 2, and we said the 1 is our x value. So we have 2 times our w1, we said w is going to be u, times -7, plus v2, which is our y value for our v coordinate point, so which is 3, times w2, which is the y coordinate for our u coordinate point, which is 9. So 2 times -7 is -14, plus 3 times 9, which is 27. 27 plus -14 is 13. So we know u times v equals 13. Now we're going to go ahead and do problem 2b, which is asking for the angle between u and v. Well, in order to find that angle, we're going to use that equation we used in problem 1 again, which was v times w equals the magnitude of v times the magnitude of w times cosine of theta. Well, if you remember, we rearranged this equation in order to get theta equals arc cosine or inverse cosine, however you like to say it, times v times w over the magnitude of v times the magnitude of w. In order to get v times w, we're going to use what we found in letter A, which was 13. So let's go ahead and use 13 for our numerator. So we're going to have theta equals arc cosine times 13 over, now we need to find our magnitude of v and magnitude of w. Well, we said v equals v and w equals u. And to find the magnitude, we're going to be using the equation, which is the magnitude of v equals the square root of v1 squared plus v2 squared. Well, we're going to use this for both equations, so let's go ahead and do v first since it is representing v. So we have the square root of v1, we said v1 is x and v2 is y. Well, if we look at our v up here, it says that v1 is 2, our x value is 2, so we have 2 squared plus v2, which is our y value, which is 3, plus 3 squared, and we take the square root of that, which is the magnitude of v. Well, we know 2 squared is 4, so we have the square root of 4 plus 3 squared is 9. 4 plus 9, the square root of 4 plus 9 is 13. So that means the magnitude of v is the square root of 13. So we can write that in our equation times, now we have to find the magnitude of w. Well, to find the magnitude of w, we're going to use the same thing. So we have the magnitude of w equals the square root of w1, let's imagine that's a w, times w2. And remember, these are both squared terms. So let's go ahead and look at our w equation, or our u equation in this scenario. And we know w1 is x and w2 is y. Well, our x value we can see is negative 7 and our y value is 9. Let's go ahead and substitute that into our equation. So we have negative 7 squared times w2 squared plus w2 squared, which is our y value of 9 squared. Well, we know negative squared is positive, so we have the square root of 49, and 9 squared is 81. 49 plus 81, and we take the square root of that number. Well, we know 49 plus 81 equals 130, and so that's going to be our second term in our denominator. And then we're just going to find the arc cosine. So now we're going to find the inverse cosine, and after calculating for inverse cosine, we get that theta equals 71.5651, and I'm just going to say we're going to go to 2 decimal points, meaning theta equals 71.57 degrees, meaning our answer for letter B is 71.57 degrees, and we are done with these 2 problems. Now we're going to go through 2 more problems, the first of which is number 6, which says, how much work must be done to lift the 15 kilogram block up 5 meters? And it says to remember that F equals ma, or force equals mass times acceleration. We're going to be using the given equation in this scenario, in addition to one of the equations we stated at the beginning of the video, which was W equals force times distance, or the magnitude of force times the magnitude of distance. Well, we know we're trying to solve for work. Well, we know we're solving for W, so we're going to try to find force and distance. Well, distance is given in the equation, so we can write it down here. So W equals, we don't know the magnitude of force just yet, but we do know the magnitude of distance is 5. So we have 5 meters. We can do 5m. All right, now we need to find force. Well, force equals mass times acceleration. We know the mass of our object is 15 kilograms. Force equals our mass times acceleration. Mass is 15 kilograms. And now we need to figure out acceleration. Well, if you think about it, acceleration on an object at any given point of time on Earth is about 9.8 meters per second squared according to physics. Well, we have 15 times 9.8 meters per second squared. Well, 15 times 9.8 is 147. So we know our force is equal to 147 newtons. So we do 147 newtons times 5 meters, and we get work equals 735. In physics, work is measured in joules, so we're going to say 735 joules. Now let's go ahead to our last problem for this video, which says, a force of 10 newtons is applied to an object at an angle of negative 35 degrees with the horizontal. The object is pulled 10 meters at an angle of 25 degrees. How much work is done while moving the object? If you remember when we started this video, we said there's one equation, which was work equals force, or the magnitude of force, times the magnitude of distance, times cosine of theta. Well, we know that force is 10 newtons, as given in the problem. And then we know the distance provided was 10 meters, 10m, and then times cosine of theta. Well, you might be asking, what is theta? Well, since we want to see the total work done, we're going to see how much our angle really moved. Well, first we moved an angle of 35, and then we moved 25. Well, 35 plus 25 is 60, so we're going to do cosine of 60 degrees. Well, now we have W equals 10 times 10 times cosine of 60. Well, if you look at our unit circle, we know cosine of 60 equals 1/2. And that is going to be multiplied by 10 times 10. Well, 10 times 10 is 100. 100 times 1/2 equals 50. And since it's work, it's going to be joules. Work equals 50 joules. And that is our answer for number 7 of this video. I hope this video helped. If you believe it did, please consider like and subscribe. We do have an Instagram, which is in the description box below. Remember to like and comment if you believe this video helped. Thank you.